Hello everyone! This is my first video on reverse engineering Swift applications and I'm very excited. We will discuss the name mangling technique. I hope it will be interesting. Let's dive in! I have created a simple application hello.swift. Don't worry, it's not hello world. I've defined a class with functions and methods, and also instance and class methods, and so on. First, we'll go through the code, see what it does, and how to compile it from the command line. No Xcode for now. Let's use our application to talk about what name decoration or name mangling means. Don't worry if you're not a Swift expert, because we will cover everything that's needed to understand this technique. Also, the code is commented. Here we defined the class with a few class properties. The third one, it has a default value. This will be a swan-themed exercise. Below, I defined the queen as the owner. You might not see the joke if you're not from the UK. Anyway, it's funny, the Queen owns all the swans in England. Back to the code. In the initialization part, I've initialized the two properties, color and name. Next, we have a class method, which will apply to all the swans. Class methods can be called without an instance. Then, we also have instance methods. For example, one example of instance method is a function to print the color, which depends on the instance because each swan instance will have its own color. Same thing with the owner. Each instance can have a different owner, so change owner is an instance method. Notice that class methods have a modifier in front. Lastly, there we have another instance method. It has a parameter and returns a value, unlike the previous one. Then, in our code, we defined two swans. One white and one black, and then we have some funny names, Mac Swan and Fluff-a-Lot. The code is straightforward. Here's how we call class methods. We need the name of the class followed by a dot and method name. To call instance methods, we first need to define an instance of that class. Here, white swan is an instance of the class swan, and we can call the methods print owner, print color, and change owner. Then, we have a second instance, black swan, for which we call the print color method. Great! We went through the code. Now let's see how to compile it. We will use the Swift compiler swiftc, then add the name of the file hello.swift. But we have an error right here. It says unable to load standard library for target. Why is that? Let's do a bit of troubleshooting. I'll check the version and the target for the compiler to make sure they are correct using swiftc-v. The target is x86_64 and the version is correct as well for Mac OS 10.15. To better understand what's happening, let's see where this compiler binary comes from using which command. This is part of the command line tools and is located in /usr/bin inside the command line tools folder. On this system, there's also another swiftc binary, which is in /usr/bin. This was the default version that was installed with the operating system. Let's test with this one and see if there's any difference. Right, this time we didn't get any error. Let's dig deeper and see what's happening. Again, use the -v parameter for verbose output and observe the parameters. This shows the full command line, including all the parameters passed to the compiler. It's important here that the command line invokes the same compiler binary from the Swift package. Very useful for us here is the SDK parameter -SDK over here. Let's copy that. Then use the swiftc command, same as above, but this time pass a correct SDK parameter. Great! Now we've managed to compile the file without errors. Let's run it and make sure it works as expected. Looking back at the code, we have called the class method, which works same for all the swans, and the output is printed here. Then we call two instance methods for the white swan, one to print the color and then to change the owner, and print the new owner to make sure it's correct. Finally, call another method for the black swan, which is a method to check if it has the same color. The code is straightforward to understand, very similar with other programming languages. What is important is to have various types of methods, one that has parameters and return values, ones which do not, and so on. We now know how to compile it and troubleshoot the code. Next, let's see name mangling in action. The free version of IDA Pro is sufficient. Open the compiled hello binary. Then we'll have the list of functions on the left. Notice that we have some strange characters and unexpected strings within function names. Although some parts of the function names look the same, like swan and owner, some of them really look confusing. The technique is called name mangling or name decoration, and it's very useful. Let's see why. For once, it's a way for the compiler to pass as much information as possible to the linker. By decorating function names, the linker will know things like parameter types and the function return type. A lot of semantic information can be transmitted within function names. A neat trick. And there's another reason why this technique is useful. Lots of times we can have multiple entities within the same name, like functions, variables, and so on, as long as they are in different namespaces. By using name mangling, we can have multiple entities with the same name because each signature will be different. Back to these names, we need to get the human-readable version. And this is what we'll do in the next video. We'll go from these names and extract the original name, plus the function arguments and the return types. So to recap, in this video, we've seen how to compile a simple Swift application, also how to debug and troubleshoot compilation errors, how to pass the correct SDK parameters, and finally described what name mangling means. There's a lot more to it, and we've barely scratched the surface, but I hope this will keep you engaged. Thanks for watching and stay tuned for the next episode. Cheers!